Hello, everyone. Hope you had an enjoyable weekend, and welcome again to Aeromotive. Today, we're going to be doing number 2 of 6 sessions of training on evaluating wire damage. And in Friday's session, we talked about the cable assembly itself, the components that make up the sum of the assembly. As we move forward, we're going to drill down a little bit further. And today, I'd like to talk to you about wire and wire marking. That's why I'm standing in front of our cut strip machine, because I'm going to demonstrate some of the inkjet processes available to wire mark a wire lead. But first, let's talk about the wire. I mentioned on Friday that there's several different classes that wire harnesses assemblies fall into. There's 3 of them, 1, 2, and 3, with the automotive sector falling into class 2 and 3 based on the application. Well, those classes also help dictate the type of wire that's going to be put into the assembly. So no, not any wire can fit the application. You really don't want to go out and get hookup wire and install that into your wire harness assembly on an automobile, right? Because it was designed for a purpose. So it's best to match it as best as possible. So I want to take a look at first wire gauge. Wire gauge comes in a variety of sizes, as you probably know, and I wanted to show you a 4 gauge. This 4 gauge is SXG or SGX. It's multi-stranded with a very thick insulation wall, and most of you might recognize this as battery cable. This particular cable has a lot of strands, which allows for, one, a lot of conductivity, but also for a lot of flexibility. So imagine this being a solid wire and trying to pass this through a firewall or running it back into the vehicle's luggage compartment to get to a battery, which is very common on a lot of European-made vehicles. So this, again, is your 4 gauge wire with about 125 strands in there, so pretty flexible stuff. We're going to drop down a little bit, and we're going to go to our 10 gauge. This 10 gauge has 19 strands. So as you can tell, not as much flexibility, and the strands in this case are a little bit thicker. It's also a GXL wire, which means it has a pretty good rating when it comes to harsh environments. And you'll see this again a lot in engine compartments and, of course, commercial vehicle lines. So I'm going to keep stepping down. That is now your 4 gauge and your 10 gauge. It's good to note at this point that there is a metric conversion for all this. And I can speak metric, and we're actually work a lot of metric design. So I wanted everybody to know that if you do see wire specifications coming your way, or you are trying to select a wire, that you can convert it back into an AWG number. The next wire lead I wanted to look at was this 16 gauge. And I wanted to show this for a couple of different reasons. And I'm going to ask Katie if she can zoom in on this. So this 16 gauge or 14 gauge has multiple strands to it. But there's a term that I wanted you to keep in the back of your mind, and it's called bird caging. And what is bird caging? That essentially occurs when the wire bundle or the wire strands get forced out from their normal twist as it's being manufactured. As you can see from here, it looks as if this is creating a bird cage. So thus the term bird caging. Why is that significant? Because you can add stress to one of these strands, and as I move further through the wire gauge sizes and types of wire, you'll get a better understanding of why it's so important to keep the form of this wire stranding the way it's been manufactured. So bird caging. The other, as I move forward, then go even deeper, and then we start looking into 22 gauge. And just as a comparison, This is your battery cable stranding. This is a 22 gauge wire. I don't see if Katie can zoom into that. Basically, your 4 gauge wire, one strand is almost equivalent to this 22 gauge that I have in my hand. That gives you an idea on how fine the wire assemblies are becoming, or these wire leads are becoming. Makes it extremely difficult to repair in the field. I'm going to, again, come back to this because this is kind of significant. I'm going to strip this for you and give you an idea what it looks like. But let's continue on. As we move further through the assembly, I want to start getting into some identification as well. The automotive industry uses color coding, which is really a nice system. I do like it. The only issue we have with it is all the different colors. We have blue, sure, but now I need blue with a white tracer. We have blue, sure, but now I need blue with a brown tracer, a red tracer, a pink tracer. So I think you get the idea. That's a lot of wire inventory, right? When it calls out for that specification, that's what it's going to get. There's just no doubt about that. But these are some examples of what wire coloring and labeling or striping is like. Now, when you look at this, and I'll go to this one as well, there is two types of wire striping. One is a spiral stripe, the other one is a straight line. Kind of hard to hit, but on the automotive side, they use straight line wire striping. So sometimes you might have to twist the wire to see what your stripe is. Whereas if the wire striping in itself is twisted around the wire, you have a better chance at glancing at it and getting an idea what it is. This might look like it's striped twisted, but it's not. It's only because this is a twisted pair of wires. So it makes it look that way. I also want to go into a little bit more on marking systems because it's going to lead up to that. Let's first step back a little bit and continue down the stranding because it's kind of significant. So I have this 22 gauge wire here, and I want to strip it back so I could crimp it to a terminal or even possibly splice it to another circuit. For that, I'm going to need a stripper. Well, let's take a look at what our options are. We have these two types of strippers, and I don't know if Katie can zoom in on that. And you can tell from the blade systems the different gauges that are available. So it's essential to know what gauge you have so you can strip it properly. I'm going to go ahead and strip back this 22. It's a nice stripper, by the way. Single action, automatic. It's kind of nice. Now, what I do with the wire lead is I'm going to fan it out because I just bought this new, for example. I just bought this spool of wire. Well, how do I know I got the wire that I was looking for? I have to strip it back and inspect it and count the number of strands. Now, even though this is a 22 gauge wire, look at the strand count on that. That is quite a few strands for a 22 gauge wire when you compare it to this. So this offers a lot of flexibility here. The problem that occurs is the stripping action or the cutting action. So what do I mean by that? Well, let me show you what could possibly happen if you don't have the right tool for the right job. I'm again going to cut back this wire lead and give you an idea of what that would look like. Okay. So I stripped it back, and what I ended up with, I chose the wrong size hole or wrong size wire gauge for this strip. What I ended up with, and it's kind of hard to tell from the zoom, but I'm going to show you. I ended up with this nicks in my strand count. Well, look at what we're dealing with on the number of strands here. how many of these can I effectively damage before I have to cut it back and do it again? Well, like anything else, there's specifications and standards for all that. And there is a standard for this. One of the standards, and I'll just throw out a number for you, for this particular wire, which is basically a 12 to 16 gauge, I can have 3 strands damaged and not have to worry about this particular wire lead maintaining its current flow rating. So that's a good thing. What happens though when I do something like that to a 22 gauge? I dramatically affect its performance. The number of strands that you could have cut in this particular case or nicked, 1. And as the strand count goes lower, you're down to 0. Again, think about the performance factor here. There's not a whole lot of strands to this, and they're very tiny. And if you do some simple math, and there's 10 leads here, 1/10 of your current capability can be eliminated by simply nicking the wire. So what's the moral of the story here? Right tool for the right job. Let me give you an example. This particular wire size, wire lead and gauge, it's difficult to find a stripper that's this diameter. So the propensity is to use a blade. Ouch. This gets really, really, one, I'm running into the hazard of cutting myself. Secondly, I'm going to get into a real bad habit of nicking wire. All right. Now, is this the tool for the job? Yes. Yes, it is. You can find a specification that will allow you to use a straight edge to cut or create a perforation in the wire lead. And if you notice my motion here, I'm like cutting an apple, right? But I'm doing it very slowly, and I'm dragging it along the top surface of the insulation. Now, I'm not going to cut this open for you because this insulation is adhering very well to this copper stranding, and I'll have a hard time pulling it apart. And it'd be more than 30 minutes, trust me. But if you can look at what's underneath the insulation, which can give you some peace of mind, there's a paper element here. That's basically all you have between the outer coating of this insulation and these copper strands. So be very careful when you're using a straight edge knife or utility knife to cut large size cable. I want to move into other marking systems. And that's why we're here today. We're looking at identifying wire. We're also looking at identifying marking systems. And there's quite a few ways of going about it. One of the most popular marking systems, as I mentioned, is color coding. But what if you can't match a color code? No problem. Let's think about labeling. This is another form of wire marking. There's a, I would say, not an industry term, but maybe a jargon out there called Brady label. And Brady labels are used to mark circuits, right? Identify components. For example, here, this particular label is used to identify a part number. This particular label is used to identify a connector. It can also go further and not only identify the connector that it plugs into, but also the circuit number, so that the circuit number is aligning correctly in your connector. So labeling comes in a lot of different forms as well. We can apply a Brady label or a wrap. And again, I don't want to throw a whole lot of numbers or specifications out at you, but there is a specification on the wrap. It's 1.5 times the diameter of the wire. So it basically gives you the opportunity to go around once and then another half. And then that helps protect basically your inkjet printing on the label. Another form of marking is inkjet, which is a good example here. And this is also what we're going to demonstrate behind you. So this is a dot matrix inkjet. In this particular case, they use it to identify what type of wire we have, whether it's RoHS compliance, who's the provider or manufacturer of this cable, again, so that we can have traceability. We need to know where this wire is coming from and is it meeting the specification it was designed for. Right? When you take something off, replace it with the correct component. So we also have dot matrix, or inkjet printing. Another very popular way of marking systems is, and we demonstrated this a little bit on Friday, is laser printing or etching. And this is a tough one to get at. I know that. I don't think Katie's going to be able to zoom in on this. But on that case, and this again, this type of wire marking is done on Teflon products, TFL, which we spoke about. And that's really the only way you're going to be able to mark this onto the wire or insulation. Ink will just smudge right off. So it does need to be laser marked. There is another hot stamping method, and you could probably get the idea of hot stamping, right? We're going to take a marking system, we're going to heat up the blades, it's going to come down, and basically like a steer, you're going to brand it. Well, again, think about that. That really has to be well controlled because you're now melting the insulation and you're getting closer to the copper strandings, and that's a whole ball of wax there. That's not a good position to be in. As we keep going with labeling systems, other items that you can consider is the flag type. This is very popular. As you can tell, this is a good, this is a nice aftermarket installation here, where they basically give you an idea of what the circuit is that they want you to plug it into. Again, you could also have maybe a connector ID number or a to from, goes from circuit to circuit. So we have flags. We have printable shrink tubing, right? We print on the tube, we apply it to our bundle, and we shrink it down in place. And a very good method also. We have vinyl tubing, which is clear, which is also very nice. The other advantage to this is the fact that it is pretty flexible, right? It does give you an opportunity to bend around corners. Another is a label, a zip tie label. And these are very good for marking whole assemblies or inspection tags, even a point of manufacture. And these come in a variety of colors, right? They come in a variety of sizes. So again, depending on the application, you might need a larger tag for a larger bundle. That's basically what determines what tag you want to use. And there's also the opportunity to, again, use shrink tubing with a combination of a Brady label to get the same type of effect, but try to adhere to an OEM specification as much as possible. I want to give a quick demonstration on how inkjet process works. So I'm going to ask Katie to swing on over, and I'm going to start up the machine behind me so you can get an idea of what that looks like. And I'm going to point out a few aspects of it as we get going. Let's start over here. In order for us to get a good print on a wire, it needs to be straight. So we're going to straighten our wire first. As we begin to straighten our wire, we're going to move it over the print head and start feeding it into the cut heads. As you can see what's going on back there, we're going to cut, we're going to strip length, and then we're going to strip the back end of the wire as well. The swing arm is going to grab the wire and it's going to bring it over to our applicator. And here's the back side of the applicator. What's an applicator? We're going to learn more about that in the following days. I'm going to have Katie, again, swing around one more time and get an idea of the feed system on a wire cut, strip, and crimp. The nice thing about this system is that we get a factory crimp every time as long as we stay on top of the tooling. Process control, process control, process control. So we're getting a nice feed. Just as an FYI, this is running at 15%. So we can really crank this thing up and start getting some volume out of it. But the main reason for the automation is the quality. Let's take a look at that. This is what we will be looking at on an inkjet. For us, the most important thing for the customer to know is the wire gauge, and that's what we're putting on here. The type, a TXL, along with a 16 AWG, American wire gauge. So the customer knows that if he's putting this onto a circuit, it should be matching at best a 16 gauge wire. Now they could go smaller gauge wire. They could go to an 18. They could go to a 20. And it starts looking a little awkward. We would then suggest, how about if we just send you the correct gauge wire? So that'll give you an idea of wire marking, inkjet. And when we come back in a couple of days, we're going to talk more about this, which is the crimp height and the crimp. Very essential. All right, I'm going to have Katie find her way back to her workstation. Thank you, Katie. I forgot to introduce Katie today. Katie handles a lot of our, obviously, our video, content, marketing, and just doing a great job. Thank you very much, Katie. I really, really appreciate it. I really do. So that kind of rounds off our session for today. On Wednesday, that's going to be the meat of the matter. I think you have enough knowledge in order for me to start discussing how we're going to go about repairing and replacing in the field. And that's what it's all about, right? We want to know what we can and can't do to a wire assembly and what needs to be replaced and what does not. So I'm looking forward to seeing you on Wednesday. Again, thank you very much for tuning in. I appreciate every moment I get to share with you folks. So have a good week. I'll see you on Wednesday. Have a safe day.